Hello everyone, welcome to your first class for steel as a construction material. So I have not been able to give you an introduction of this topic, but I hope that you will be able to understand like this. So hi, let's begin. So the first slide is history of structures. मैं आप लोगों को ये presentation पहले ही भेज चुकी थी, तो I hope that you have read all this, but we will just have a quick overview. You all know that the old structures were made to be load bearing, in which the walls bear the loads and the flooring and roofing is done with wood or timber. And in areas where the cold climate is there for most part of the year, they needed coal fires and oil lamps for lighting. इसकी वजह से बहुत बार फायर्स डिजास्टर्स हो जाते थे फैक्ट्रीज के अंदर which caused a lot of issue for the management, for the institutions which were running these buildings, and for the people as well. Then came the steel structures which were introduced so long ago, 1792 or 93. So the first fireproof mill was made in Derby, England by William Strutt. And the special thing about this building was that the walls were load bearing, but there were cast iron columns with the load bearing walls to support the timber beams. This had not been done before this time, so it was a very crucial time in the history of structures. Now, after cast iron was being used in columns, people started using them in place of wooden beams as well. So पहले ये था कि कॉलम आयन का बनाते थे, साथ में स्ट्रक्चर थोड़ा कम लोड बेयरिंग होता था, पर लोड बेयरिंग ही बनता था, और जितने भी हॉरिजॉन्टल मेंबर्स हैं, मतलब बीम्स हैं और फ्लोरिंग हैं, वो सिर्फ वुड की जाती थी. बट देन आफ्टर all these things happened, मतलब डर्बी में वो बिल्डिंग बनने के बाद में कुछ सालों बाद में they started making cast iron beams also. But cast iron के साथ में प्रॉब्लम थी कि it did not have as much strength, तो उसके अंदर structural failures होने लगे and it was replaced by wrought iron. So wrought iron replaced cast iron. Then upon conversion of iron to steel, जब ये प्रोसेस परफेक्ट कर ली गई कि आयरन को स्टील में कैसे कन्वर्ट किया जाता है, उसके बाद में माइल्ड स्टील एंड देन इवेंचुअली स्टेनलेस स्टील ने कास्ट आयरन और रॉट आयरन को रिप्लेस कर दिया. So up to 1897, wrought iron was cheaper, so it was being used. They did not have the cost cutting techniques to make steel cheaper, so they were using wrought iron only. And the example of the first structural steel framed building to be erected in England is the Ritz Hotel, where whole masonry is carried by a steel frame. I hope that you guys will study about the Ritz Hotel and the structure, and if you want you can write about it in your sketchbooks as well. Now, till the Second World War, majority of the structures were being built with steel frames, but बाहर उसके अंदर cladding जो करते थे वो brick की करते थे to give the impression of a load bearing structure. After World War II, इतना ज़्यादा use हुआ steel कि they got a shortage of steel after World War II. So during that time, uh, what building material flourished is reinforced concrete. So they used to have concrete, but they started using it as reinforced concrete up until the 1980s, and after this steel production flourished and steel became cheaper. Now let's come on to steel. Steel is an alloy of iron and carbon with very tiny amounts of other metals to give it a particular property. What is an alloy? That is the first thing that you need to understand. An alloy is when you mix a certain metal to a pure metal, which is kind of creating an impurity in a pure element to change its physical property. अगर आप किसी normal या pure element के अंदर कोई दूसरा element एक certain proportion के अंदर mix करते हो और उससे होता ये है कि जो आपने प्योर एलिमेंट था उसका फिजिकल प्रॉपर्टी को चेंज कर दिया, वो अलॉय होता है. ये सबसे सिंपल भाषा में जो मैं आपको समझा सकती हूँ वो समझा रही हूँ. सो आयरन ओर इज Iron ore is melted on high temperature in a furnace and then alloyed with carbon to make steel. So what did you understand is that iron ore plus carbon makes steel. The carbon content varies from 0.1% to not more than 1.7%. So there is a certain amount of carbon which is mixed with iron ore and other metals to create different kinds of steel. So the quantity of carbon affects the physical properties of steel as per proportion of the carbon and iron. So let's understand what less carbon does and what more carbon does. When the percentage of carbon is increased, it increases ductility. Ductility is the ability of a metal to not break upon uh, putting exertion on it. When you stretch it, it's ductility, and when you compress it, it is malleability. So when you stretch it and it turns into a wire, it's a ductile material. So if there is less percentage of carbon in steel, it will be more ductile. So you can create strings out of it or wires out of it. And when there is less percentage of carbon, it gives you ease of welding. What is welding? Welding is the technique in which you can join two separate members to create one member by fusing it or welding it in places. Now, when there is increase in the percentage of carbon, what happens is that there is an increase in tensile strength. Tensile strength is when you exert the tension on a structural member. So if a steel member is exerted upon with tension, it does not break or it does not fail. So that has a good tensile strength. That member has a good tensile strength. The material becomes hard on more carbon percentage in the metal, so it does not fail, it does not develop cracks. उसके अंदर cracks नहीं होते, वो member fail नहीं होता और उसकी strength अच्छी होती है. And ease of casting. What does casting mean? Casting means molding a material as per a given mold or shape. So if you think about it, if there is a high percentage of carbon, the metal can be molded into different shapes easily. Now I want you to please search steel from start to finish on YouTube and see the process of steel being made. You can pause this video, watch that video, and then come back to the next. Now, structural steel has to have a carbon content from 0.16% to 0.25%. It has to do with the strength of the material, the tensile strength, the ductility, the malleability, and all the things which are needed to determine what kind of a substance is coming out. So structural steel has its own reservations. Now there are categories of carbon steel. So carbon content of steel ranges from 0.05% to 1.7%. For carbon steel, I am talking about only carbon steel. So there are these four types of carbon steel which are there available in the market. So low carbon steel There's mild steel, which we use in construction. These are two relatively, these two are relatively soft and can be subjected to extensive cold working. So then there is medium carbon steel and high carbon steel, and the last one is carbon tools steel. So this is the one which is used to make tools. This is not used structurally because the carbon content in it is very high. In mild steel, low carbon steel, there is more ductility. The materials are little bit soft as compared to medium carbon steel and high carbon steel, as they need to be yielded, as they need to be changed as per need on site. Now, you all have understood that there are structural steel members with certain type or certain amount of carbon content in the steel, and hot and cold rolled products are there. So, hot rolled steel and cold rolled steel. So, hot rolling is a mill process which involves rolling the steel at a high temperature. Then the steel's recrystallization temperature, the temperature which it is rolled on is more than its recrystallization temperature, which means that there is a certain temperature after which the steel recrystallizes or starts taking its own shape of the molecule back. So this temperature over which hot rolled steel products are made is higher than that temperature. So it is typically cheaper than cold rolled steel due to the fact that it is often manufactured without any delays in the process. So while the steel is being made, you can make a hot rolled steel right there and then, and it is produced and it is done using computer controlled rollers, so it is easier to execute while the metal is being made, steel is being made. Now, what are the uses? So hot rolled steel bars are used in welding and construction trades to make railroad tracks and I beams. So as you can see, this is a I-beam, this is a column, this is a channel, these are angles, this is a T-beam, and many other members that are being shown here. This is a hollow member, this is circular, this is square, and this is rectangular, and all of these are used in different places in structural elements and whatnot. Then there is cold rolled steel. Now, cold rolled steel is hot rolled steel that has been cooled down and further processed. So, it is further processed in cold reduction mills where the material is cooled down to room temperature. Then it usually uses four type of processes: cold drawing, turning, grinding, and polishing. So cold drawing is increasing the yield and tensile strength, and it is a process in which they test and then make adjustments as to how tensile and how yielding the material is. Then there is turning, which gets rid of the surface imperfections. So whatever imperfections are on the surface, they get rid of it by turning. Then there is grinding, which you already know what grinding is, that it narrows the original size tolerance, that it creates a similar kind of a surface over the whole member. And there is polishing, which improves the surface finish. So as you can read it here as well, that cold rolled steel is better in tensile strength than hot rolled steel. Then let's come down to the thing which we use in construction, that is mild steel. It is used for construction steel work. It is strong in tension and compression. So both the things are sorted here. The high value of module of elasticity, that is high modulus of elasticity, it makes it stiff and a strong material, and it is ductile. When you exert pressure, when you stretch it, it stretches, it does not break. So that proves that it is not brittle. Now it can suffer strain beyond elastic limit, and it is resistant to corrosion. Now the only main thing as per our syllabus that we need to understand about mild steel, that it provides fire protection. Protection from fire. It does not mean that it is fireproof. It means that it is non-combustible but loses strength only when the critical temperature is reached. So uh, to make mild steel fail, you need to reach a certain temperature, and it needs fire protection. We shall study what fire protection, how you can, what is fire protection and how you can provide it for mild steel or structural steel members. Now this is a weathering steel also. Addition of certain metals to create alloys which prevent rusting and provide further strength by altering the molecular structure of the metal. Now this is necessary that you create an alloy before using it as a structural material so that the weathering in the steel can be stopped. Now the characteristics and advantages of functional requirements. So the main good thing in steel structures is that there is speed of assembly. You don't need as much time as you need in casting RCC structures. There is accuracy. All the things need to be worked out before construction is started. The size of the member, the weight that it can carry, and all those things. Now, it is cheaper than reinforced concrete structural frame in the longer run, as you need a lot of raw material into creating reinforced concrete structural frames. All you need is a skilled person who knows how to construct a structural member for constructing with steel, and there is less maintenance. Once you have done the thing which you need to do to prevent rusting, to prevent weathering, it is good to go for a longer time than reinforced concrete structure. Now, the functional requirements of a steel structure are the strength and stability, its durability, and fire safety. So all these things are worked out beforehand before you start building a structure in steel. Now, these are standard rolled steel joints. So, hot rolled steel sections like we have seen before. This is a universal beam and this is a universal column. Now, the beam has more depth and the column has more thickness of the web and flange. I hope that you can understand why that would be, that this is not as deep as that. These are joists. These are smaller members which are used in floor construction or in making smaller beams or having a center to center distance between an array of beams which are placed maybe in a smaller span. Then this is a T-cut structural member from the universal beam. So the beam that you have seen before, they cut the lower member out of it and create these T-beams. And this is also a structural T cut from universal column. So this has more thickness than this. This has been cut out from a beam, this one, and this one has been cut out from a column. Now this is a channel or a C-section. It looks like this. It's a equal angle, the second one. So this distance is equal to this, and the third one is an unequal angle in which this may be longer and this may be shorter. This may be longer and this may be shorter. Now this can be custom made, this can be made out of a channel, but it is made as per need or used as per need. This is a picture of the largest and smallest section in the serial size of the universal columns. Now this is a kind of beam that is used called a Castellar beam, in which a normal beam has these sections cut out from inside to reduce the weight of the beam and to provide a better aesthetical value to the steel structures sometimes, or it can be used to reduce the size of the beam. uh, you can see this example as to how these beams are being used. Now you can see that the whole structure is made out of steel. So using this kind of beams has given the structural strength which is needed, since they are using the whole member, but all this has been cut out. So it reduces the weight of the structure by a very good amount. Now this is the kind of adjustments that are made for a Castellar beam. They can cut the beam like this through the dotted line, as you can see, and then once this has been this is detached from one another, it can be placed like this. You can see A1 has been flipped here and placed here, and B2 is where it was, and the whole becomes B, the size which is bigger, and the smaller size becomes A. I hope you have understood that. Now there are uh, cold roll formed steel sections. This is an angle section. As you can see that this has been made by turning the member. This is a T section which has been made by turning this thing like this. These are not separate members, but it has been made out of one single member by turning and folding it. This is a C section or a channel section, and this is a box channel section. Now, using cold I section and T sections can also be made using two channel spot welded back to back to form a beam section. So they've used two channel sections and attached them like this to create a I section. And the similar thing they have done with a box section as well. And they've created a hollow member like this. So there are several ways which you can use to uh, mold and create different kind of members using cold or hot roll sections. Now, what kind of connections do we use to uh, create different members, or in our case we have to study beams and flooring and trusses. So what are the type of connections that are used in steel sections? It's fasteners, bolts and welding. So this is a rivet. A rivet is a fastener in which you can see in this, what you do is you put the rivet inside a hole, and on the side, on this side, you hammer it, and when you hammer it, it creates a bulge like this head. So if this is a member through which I am going to put a rivet, if I put it here like this, I inserted it in this direction, this part is hammered, and on hammering it bulges like this, and this hole is closed off. That is how you use a rivet. So this was used more in the old times. Now you have bolt. You can't see the picture, I think, but there is a bolt here. This is a nut which is usually used as a spacer, or sometimes as a not a spacer. It is used to put in these threads to secure the bolt in its place. The bolt has a head which looks similar like this. Then the third kind is welding, of making a connection is welding. These are the different kind of welding that is done, in which this is one member, this is another member, and you weld here. What welding does is it accumulates a material where the connection needs to be done using heat. So this is the fusion phase, this is the weld phase, this is the reinforcement, and this is also the fusion phase. So this member and this member are being fused together. So that is why it is the fusion phase, and this is the weld phase. This is where the welder puts his material which is going to melt and fuse these two members together. Then the other way is this one member and the second member. They have some distance between them, and the welding is done in a way that it gets filled with the material you are welding with. So all this is external material or the reinforcement, and this is the weld phase. These two are the fusion phases. This is called single V-butt weld, and there are these kinds of 4 different kinds of welds are there, and fillet weld is also there, which is formed in 3 runs. So this member is first welded by this, then these are merged together and reinforced using this, and then the third weld seals the deal and it is completely secure. If you don't understand what I am explaining to you, please ask questions. When I say ask questions, I do not mean in the comments. You ask me on your Google Classroom and I will answer all of them. Now the topic that is a part of your syllabus is steel floor or industrial flooring. So what are the requirements of a steel floor? It is strength and stability, resistance to weather, durability, freedom from maintenance, and fire safety. All the things which you need to understand in a steel structure, which we have discussed before. So the thing which is most important is fire safety. Now, fire resistance is the quality of an element of the building structure to resist fire for a specific period of time. Fire resistance is the thing which you have to understand and achieve in a building, not fire prevention. Nothing can prevent a fire from burning a building down. Only time can be reduced. See, fire affects different materials in different ways. This is a well-known fact that uh, wood will burn faster than reinforced concrete. Reinforced concrete will burn faster than a steel or a metal structure. So, understanding this is most important. For example, reinforced concrete's fire resistance depends on the aggregate. So the kind of aggregate that has been put in a reinforced concrete member will determine how much time it will take to fail. Steel's ability to resist fire depends on the critical temperature, which once reached caused the steel to fail supporting the building. So it can take 1 hour, 2 hours, 3 hours to reach the critical temperature when the steel structure will fail, and that is the amount of time which can be used to either control the fire or get out of the building. Now, fire protection of structural steel work. There are sprayed coatings, board casings, performed casings, plaster and lath, and concrete, brick or clock casings. We shall discuss these. This is a universal column around which there is a sprayed vermiculite or mineral fiber casing. Over here it is in the column and over here it is on the beam. So the type of coating that can be done are mineral fibers mixed with inorganic binders, vermiculite, gypsum or cement spray. So you can either spray a coating of these things on a structural member to protect it from getting exposed to fire. The second one is board casing, in which you create a casing made out of boards, which can be low density boards casing as fire protection. So when you create a case around it, it creates kind of insulation, which does not let the structural member be harmed very easily. But I am telling you again and again, you cannot avoid fire to penetrate these materials also. These are not fireproof, they just stop the fire from reaching the structural members sooner. So there are steel strips of 75 width with 50 downstand edges fit over beam at 300 centers as fixing for boards. So these boards are put along, and these metal strips are put over it to clasp the boards together. Now there is lath and plaster casing. So these are also board casings only, but the material is different. Board casing fixed around column and secured with screws at 230 centers. So there is a certain distance at which the screws are put in, and this is for a column and this is for a beam. And this is another kind of board casing, in which the sections which are being used to protect the structural steel members are precast. Now here they have put a lath or a mesh before the board casing to provide further insulation to the structural members. Now the structural steel members are being protected using reinforced concrete, brick or block casing. So this is the steel column, this is the steel mesh reinforcement which is being used to keep the concrete in place, and this is the solid concrete cover. Cover is the distance which you give between the member and the minimum distance that you need to provide. So this is also another way in which you can provide structural steel with protection. Now this is the plan to a structural steel floor, fireproof flooring or industrial metal flooring. So these are I sections which you see here, which has been denoted by steel pillars. These are the main beams which you see here over the columns. So as you all know very well that wherever we have two columns, we put a beam over it, which completes the structure of the building. So that is the same thing that is happening here. These are the steel pillars, 1, 2 and 3, and similarly 3 here, and over them there are beams. Now these are the secondary beams which are placed here. As you can see, these are the secondary beams. The ones which are placed like this, these beams are the main beams, and the ones which are horizontally put, when as you are seeing this plan, the ones horizontal are secondary beams. Now let's move on to the next slide. Okay, so let's have a look at section EE here. This is the main beam, and this has been fixed to something using these two plates that you can see, and these are the bolts which are used to fix this. So these are 20 dia rivets. We have seen what a rivet is, and these are used to fix this mild steel angle cleat. So we learned that angle was either equal or unequal, and this has been used to fix this main beam. using rivets. Now this is the secondary beam. So this is the secondary beam which is going through the main beam, and both of them have been fixed using angle cleat. Now this is a layer of concrete which has been shown to be 190 mm, and all this these smaller sections, steel sections, these are filler beams which are there just to support the flooring. The concrete will crumble if it does not have any reinforcement. So above that there are spear point floor clips which are there for maintaining the spacing, and there is the flooring which can be wood or any other material. Now this is the concrete casing which is done around the main beam to protect it from fires. Now this you can see here, we have discussed this before during the stone chapter, that the stone when you use an I section for a stone flooring also, you need a casing around it. So that is what has been done here also. We will see a view of this, but after another section. Now this is section FF, as you can see here. Here you can see that this is the secondary beam which has been fixed to the main beam using similar cleats and 20 dia rivets or bolts. Now these are the clips that we saw in the previous slide, and these are 50 by 50 bearers secondary beam. These are the beams which are the beam which was there to provide the concrete some support. And you can see, you can imagine, you should imagine that these are the sections of the same place in two different directions. Now we'll have a look at the view. Now this is a sketch which is showing the beam in section EE. This is the beam from section FF. Now this was the one which was visible in section EE, and it was passing through the secondary beam. It is fixed using cleats. So the view shows that the angle is placed like this. The beam is going through it, and there is another angle which is being placed like this, and it has been fixed using bolts. Now these are the secondary beams or filler, not the secondary beams, the filler beams which have been provided inside the concrete casing, and there is flooring, and these are the floorboards as you can see here, and these are the bearers which are bearing the floorboards, and these are the clips which are creating a certain distance between the concrete flooring and the wooden flooring. I hope that you have understood this. If you have any doubts, please feel free to ask me on Google Classroom. Now this is another type of floor construction. Here you can see that there is a hollow reinforced concrete floor unit here, and this is the beam which has been provided. Now this is the I section which has been encased with concrete, and over it there is a structural concrete topping. So this is structural. It can be reinforced, it may or may not be reinforced as per the need. So this kind of a floor is a composite floor construction in which a structural steel member and reinforced concrete both are used. Now this is another type of roofing that is also done for providing structural members as structural steel members and fireproofing in the roof. Here, the steel deck, this deck has been used as a permanent formwork. You have read and you have understood what formwork is. It is the temporary structure which gives the form to the reinforced concrete that you want to give the shape to it. So here it is being used as a permanent formwork, which means that you don't take out this decking from under the floor. Then there is this reinforcement and there is concrete filling. All these things are being supported by the steel beam. So this is cold rolled steel deck and concrete floor. This is another kind of a way that you can use structural steel members with reinforced concrete. So this is also kind of a composite flooring or roofing. Now, I hope that you have understood everything. I'm saying it again. If you have any questions, please ask me on Google Classroom and I will answer them, whatever your queries are. Thank you. See you in the next lecture.